Alright, a problem from section 4.4 in your lab assignment. It says find the limit. Use L'Hopital's rule if appropriate. We have the limit as x approaches 0 of a cosine x minus 1 plus 1/2 x squared. All that divided by 4x to the fourth. And just want to point out that if you put 0 in for these values, you get cosine of 0 is 1, 1 minus 1 is 0, and 1/2 times 0 is 0. The denominator is also going to be 0, so we do have an indeterminate form, 0 over 0. Now that we know that, we can use L'Hopital's rule, and L'Hopital's rule tells us we can take the derivative of the numerator and the denominator separately. A derivative of cosine is negative sine x. The derivative of 1 is 0, so we can just ignore that. The derivative of 1/2 x squared will bring the 2 down, so that would just be a 1 times x to the first power. And the derivative of 4x to the fourth, that one is 16x to the third power. That's pretty straightforward. So we have derivatives. Now that we have derivatives, we can take the limit, or try to take the limit, and the numerator here, if you put 0 in, will be 0 plus 0, or negative 0 plus 0. It's still going to be 0, and the denominator is still going to be 0. So it looks like we're going to have another indeterminate form here. So let's continue on. We can take L'Hopital's rule as many as we need to, as many times as we need to, as long as we keep following the rules. So a negative sine, the derivative of sine is positive cosine, but there's a negative in front, so it'll be a positive cosine x. And then we have a plus 1. The derivative of x is 1. And the derivative of 16x to the third power would be 16 times 3. That is going to be 48. That's 48x squared. And we'll put them as a numerator and denominator again. We'll take the limit as x goes to 0. You have negative 1 in for cosine of 0, plus 1 is 0. And then we got 0, 0 over 0 again. Now we're hoping that we'll eventually get this to not be indeterminate, so that we can finally make a conclusion for L'Hopital's rule, but we'll see how it goes. Here we'll take the derivative of negative cosine. So the derivative of negative cosine is negative sine, so that's positive sine x. And the derivative of 1 is 0, so that's gone. 48 times 2 is 96 x to the first power. And if you can look ahead, it's still a 0 over 0, because sine of 0 is 0. 96 times 0 is 0. I have a feeling that we're going to do this one more time. Alright, the derivative of sine is cosine. The derivative of sine x is cosine x. And that's it. Now if we put 0 on the cosine, that's going to be 1, so it's no longer going to be indeterminate. And derivative of 96x is just 96. So now, as x goes to 0, cosine of 0 goes to 1, and 96 is a constant, so that's going to be 96. So our denominator is going to be 96. Our numerator is going to be 1, so it looks like this is going to be 1 over 96. And since that is no longer indeterminate and we've found an actual value, your original limit is going to be 1 over 96. Okay, so we did L'Hopital's rule several times, as many times as we needed to, until we come to an expression that is not an indeterminate form anymore. So at any point in time, if it becomes not indeterminate, then you have to stop taking L'Hopital's rule and make a conclusion. In this case, our conclusion came after several times, but we have one now. It's 1 over 96.